Hello, folks. Welcome to the show. Jack Zhao, your host with the East West, hosting this show with lots of pride because, like I said 1 million times, there's always opportunity of meeting different people, big shots, sometimes very big shots, super big shots on some keen issues. So today with me is a good friend of mine, Mr. Drexel Smith. Welcome to my show,
Jack,
Drexel.
it's always great to be with you.
All right, sure. Same here. And Mr. Drexel Smith is a retired scientist, and he's been working for the national defense for over 20 years, right? Okay. And since then, he's been involved in different areas, helping people putting out projects. And right now, he is a consultant of a U.S. firm uh, involved in some nuclear energy programs or projects with China. Am I right?
That's correct.
Sure, sure. And you just recently went to China?
Yes.
Yeah, tell me something about the trip, please.
Oh,
If there's
Jack,
any secret.
it's always good to go to China.
Okay,
China is
yeah.
a wonderful country, and I enjoy being with the people very much.
Mhm.
This particular project I started before I retired,
Mhm.
and as you may know, that the Chinese purchased the first 4 of the Westinghouse AP1000 nuclear power plants.
Mm.
And this is a new advanced design
Mhm.
that's viewed to be much, much safer
I see.
than older
Mhm.
light water reactor designs.
I see.
And after an intense competition, the Chinese selected the Westinghouse projects.
Mhm.
My involvement was to look at the safety issues related to these power
I
plants.
see. I see. All right. And how long did you take? Did it take you?
Well,
I mean the trip.
yes, I've been working on this particular project, and my customer is a U.S. engineering company
Mhm.
that is supporting SMPTC, the State Nuclear Power Technology Corporation,
Mhm.
which is a fairly new company, but they're a state-owned and privately held investment company
Mhm.
that owns all of the nuclear technology in
I see.
China.
Uh-huh.
And they will be the owners of the power plant,
Mhm.
as well as responsible to develop the nuclear technology going forward for China. And our work with them is to help them be sure that the safety systems are indeed adequate, and to help with technology transfer,
I see. I see.
so they can, in the future, build the power plants on their own. And their desire is to be able to build those new facilities to the U.S. standards.
How long have you been involved in the whole project? You mentioned you started when, maybe even before your retirement.
This particular project, I started almost 6 years ago when the Chinese was in the process of negotiating
I see.
and selecting a vendor, and began to be very involved when they made that selection
I see.
in 2008 of the Westinghouse technology.
All right. How long did the trip take?
Well, this particular trip, my last trip, was only 10 days.
Only 10
We had
days,
meetings in the headquarters of SMPTC is in Beijing.
Was that the one when I called you said, "Oh, I'm on a cruise ship, whatever"? Was that the one?
No, that was a
No.
different trip. But SMPTC is headquarters in Beijing, and the leadership of the Research Institute is in Shanghai. So our meetings typically are in both cities.
All right. So Drexel, every time when you're here, I try to take advantage of your presence to educate myself. I'm a guy who has a huge lack of the whole area, any knowledge of the whole area. So to back up a little bit, the invasion of nuclear energy is really a bliss. However, it looks to me, or to everybody else, the same thing as a double blade sword, right? Take Albert Einstein, for example. he, during World War II, he was one, or at least one of those who recommended that the United States should do the atom bomb, right? Sure enough, we did it, and sure enough, we used it. And then it was not until during his late years, or during his declining days, he regretted heavily. And he even wrote a letter to one of his best friends saying how deeply he regretted he was involved. So as a scientist yourself, how do you assess this particular double-bladed sword?
Well, I guess, Jack, yeah, bluntly and candidly, I share with you, many people have very mixed feelings of involvement of the development of any weapon that's used for mass destruction.
All right.
On one hand, you want to win the war. On another hand, it's horrible for civilization. So I really don't have any personal expertise in nuclear as it relates to weapon systems. I have a long involvement with nuclear power technology and the use of using that technology for the development of energy.
All right.
And specifically the evaluation of safety systems for commercial nuclear. So there's another great quote by the great Albert Einstein, and that is that if we continue to do the same thing over and over, it's called insanity. And insanity is to burn carbon-based fuels to make electricity.
I see.
If what we're after is power at the end of the socket, what we do is we use it in the most inefficient way possible. We take some carbon fuel, be it coal or oil or something, and we use it to burn it, to make something hot, to heat water, to convert it to steam, that converts to a turbine, that turns a generator, that manufactures electricity, that we send over wires with a tremendous loss for every mile that it goes, because it's a tremendous inefficient system. Whereas in nuclear, we're using a fission process where we have small pellets of fuel in a rod, and when they interact with each other, they create heat. And we use a similar process that we take that heat away by putting water through the system.
All right.
And that water converts to steam to generators.
All right.
So even with nuclear, we're still not solving the transmission problem, but we are very efficiently using the heat generated from nuclear fission to create steam that can then do work for us.
But in your eye, how far is it from the point you decided to make it a nuclear power, or and the point you decided to make a nuclear bomb? Like, for example, if I am casting some steel, right? By the moment I'm casting, I know exactly if I put it in this mold, I'm making a sword with it. If I'm putting it in the other mold, I'm making a cooking pot of it,
Well,
right? So how far is it between the two?
the simple fact is that the fuel used in a commercial nuclear power reactor is very low-grade fuel.
I see.
It is not usable, suitable at all as a weapons-grade fuel.
I see.
That fuel needs to be highly enriched by a completely different process to get uranium that's enriched enough that can be used as a weapon.
All right. Okay. So, right now, everybody's talking about a uranium project, uranium nuclear programs, right? To your knowledge, as a scientist, how far do you think they are from the point of turning this into nuclear weapon grade?
Well, in the U.S., we have a requirement that we can only use the fuel through one cycle. with that, we're generating too much waste and we're not using much of the fuel. If we could enhance that fuel, we could get far more power from the fuel. But the stopgap is we don't want the fuel to be enriched because it gets you on a pathway
All right.
for weapons grade
I see
fuel.
what you mean, yes.
So the double-bladed sword that you speak of has more to do with our ability to enrich the fuel and make it even more usable for power plants. We could reduce the quantity of waste and increase the life of the fuel if current power plants could use enriched fuel. But right now around the world, we don't do that. So the consequence of that is that we are indeed generating waste that will last for thousands of years. That is a problem. But the other side is if we use the more enriched fuel, now you have the potential issue of having more fuel available for weapons. So when you look at the entire energy spectrum, I think we have a limited supply, and we can argue forever about exactly how much coal and oil we have, but digging it out of the ground, there's a fixed amount.
I see, of course.
And the question is, should we take that resource and simply burn it to make heat when there's other ways to make heat?
All right.
My argument is, I don't think we should use one drop of oil
Okay.
to make heat.
Again, you were quoting Albert Einstein that not to repeatedly do the same mistakes that you used to do. So prevent yourself to be insane, right?
Exactly. And my point is that nuclear burns clean.
All right.
It does not have secondary environmental consequences. The entire process allows you to make tremendous amounts of electricity
Sure.
with a very low carbon footprint. So from that perspective of the environmental issue, the abundance, there's an enormous supply,
All right.
its usefulness, it is a tremendous technology. Again, the downside is how do we manage the waste product, and how do we make sure
All
that
right.
it doesn't become in the hands
All
of
right.
people
Okay,
as a
good.
potential weapon.
Sure, good. Let's take a short moment now. When we come back, we'll probably just squeeze hard to find from Mr. Drexel Smith any necessary knowledge to build ourselves up, right? So stay with us. We'll be right back. Hello, folks. Welcome back to the show. Jack Chow hosting East West with a good chance talking to Mr. Drexel Smith, and he is a advisor and consultant of a U.S. energy firm who is now involved with China with a nuclear power energy program, huge one. He just came back from China, and I dragged him over to talk not only the project, but to find out the essence, how we can prevent, prevent this whole thing in turn into weapons, such as the uranium situation. And on the other hand, we try to make the good use out of it, make 100% out of it to benefit ourselves. That's called purpose, the safe use. And the previous called peaceful use, right? Okay, now, back to uranium though, because when anybody talks about nuclear energy, you can prevent talking about Iran first, because they're the biggest head scratcher at this very moment, right? So when people say uranium enrichment project, when they say that, they really refer to the fact that they are enriching the raw materials into certain commercial degrees, or they are enriching them from the commercial degrees into military degrees.
Well, the concern is that we believe in our government that Iran is using technology or developing technology of high-speed centrifuges with its principal use to develop very high-grade, weapons-grade uranium isotopes. That's the fear.
They are doing it. We have evidence saying that they are doing it already.
I believe, according to the press, that they are developing that technology. I'm not educated enough or informed enough to know where they are in that process.
All right, okay.
But we seem to have some very strong evidence that they are developing the high-speed centrifuges that are specifically designed for the highly enriched fuels that allow you to use a weapons grade.
All right, okay. Back to another fact though. When we dig coal out of earth, we make a hole there. Well, the coal come out, right? So we have to find a way sooner or later to fill it up, otherwise it's gonna crack, right? So when getting the uranium, do we have to mine uranium, or where does it come from?
Well,
I know nothing about it.
So far, the coal mining all over the world, we've simply left the holes in the ground.
Yeah.
I don't think we've ever dealt with the environmental consequences of that. And remember, China is now one of the largest users of energy, and its number one energy source is coal. And the coal that they use in China is not very clean coal. Coal comes in various grades like other types of
Yeah,
fuels.
of course, yes.
And quote, dirty coal means that it has a high degree of sulfur and other contents
Yes.
and pollutants that when you burn it,
Yes.
those pollutants don't burn.
Like what
They
now-
contaminate.
Like right now, what is happening in Beijing.
Exactly. So ironically, the U.S. only has a small part of the population in the world, but we consume 80% of the energy resources. That can't continue. We talk about a concern of uranium used for weapons. My bigger concern that if we don't develop technology that everybody has access to electricity, that we're going to have arguments about natural resources.
All right.
When you have 20% of the world using 80% of the resources, that's bad business. When you have 2/3 of the world that doesn't have adequate access to electricity, at some point, they're going to want access. And India, Africa, and some places in China
I see.
simply are going to want to have access. So out of the roughly 7 billion people in the world, over 2 billion have no access to electricity at all. So where are the resources in the future going to come from that allow them to have access to power?
All right.
To me, when you look at all of that and you say, okay, let's look at renewable energies, wind, solar, etc., they can only represent a fraction of the demand for energy. When you really look at the world demand for energy and the demand when the 2 billion people that have zero want some, and the Western world to continue to be a robust economy, continue to meet some, all of a sudden,
Nuclear.
the solution is nuclear. So China right now is looking at the need for as many as 50 nuclear power plants.
Where does this raw material come from? Rare earth?
Yes, there appears through all projections to be a significant into the future non-competitive supply of uranium and the relatively low grade needed to heat water that you use in a power plant that should be adequate for our energy needs into the foreseeable future. And I would say, to me, that's at least hundreds of years. So I don't think we have a natural resource issue with uranium. What we have is a very significant issue to make sure that we can safely operate and maintain these power plants, because failure is not an option. What we have is a worldwide issue to come to grips with how we manage the waste byproducts from these facilities.
All right.
I believe both of those are technical answers that are in hand. It's a matter of the political will of wanting to do that. And if I might just add, Jack, the project that I've been working on in China with SMPTC is their very strong desire to want to make sure that their safety systems equal or exceed US and international standards. That's why they're reaching out to experts in the world to help them assure that they can operate these power plants that they're building safely.
All right. Okay. That answers the question, I mean, partially to the fact that how you should safely use it, but how you should peacefully use it. That's the other issue, which is bigger. The fact I brought this up is because, in comparison, if you turn the same kind of energy, same kind of efforts, when I say energy, I refer to efforts, human efforts, same kind of human efforts and the money and everything into solar energy, though, do we get the same or similar or close amount of energies that we need?
Absolutely not. If you just drive north of Los Angeles and go out to the desert and look at one of the larger solar projects that's ever been put together, and you look at the number of square acres that it takes to consume to put in 100 megawatts of power, it just is a graphic example that you just can't get from here to the energy demands throughout the world using solar. Now, quickly said, is solar very applicable in many cases? Should we build every house with a solar collector that we can use to heat our water or supplement? The answer is sure. Let's use the technology where it fits. But is it going to fit our electrical generation demand throughout the world? I don't think so.
I see. So you're promoting the idea of separate them, right? To create energy through solar system, through solar cells, whatever, for a certain purpose.
Exactly.
And for the majority, great majority of the inquiries, such as our cars, such as gasoline burning, such as coal burning, to replace them with uranium.
Well, the answer is yes. And for example, I find it quite humorous that many of the environmental community says the answer is electric cars. Well, because today in the United States we have an abundance of electrical power, and people in many cases are incentivized to plug their car into the socket. They're often not even paying for that power. That's a temporary issue.
Oh, yes.
If they look at the absolute ineffective and inefficient use of what it took to burn something, to create steam, to turn a turbine, to get the electricity.
And loss in the transfer.
Exactly. To their car, they would realize that we need a far better way to generate that electricity.
Sure. I've got a friend who works at SEC, Southern California Edison. She is the manager or whatever, or planner or whatever you call, for the high voltage power, I mean transforming, right? She says by the point it is generated from the system, it was 500,000 kilowatts.
Okay.
And during the transfer, when it reached to the poles on the street, it goes to no more than 50,000. So in other words, 95% is lost.
Yes.
So, okay, now I am thinking about using the present coal or present gasoline or petroleum fuels as we do. And then can we put the same efforts as we do to the nuclear development into the transfer so that we can recover, reclaim those 95% lost on the way of transportation?
Well, many people have been thinking about
And
this.
considering the fact that for that we always have to worry about the weapons degrees concentration, right?
Well, one of the ideas is not to build very large plants. Like here on the coast at San Onofre, each one of those power plants, of the two we have operational, or today shut down, but they're about 1,000 megawatt plants.
All right.
Instead of building 1,000 megawatt plants, maybe we should build a larger population of 50 megawatt plants.
Oh, smaller ones.
Putting a plant in a neighborhood that minimizes this transmission loss issue.
I see.
But on the other side, there is a lot of interest and a lot of research being done in how to make the transmission loss less. For example, should we subcool a hydrogen-cooled transmission line can minimize the loss.
Superconduct.
Superconduct.
Okay, let's take a moment out. Probably we talk about superconductivity. I don't know, I'm kidding. So we'll be back. Hello folks, welcome back to the discussion. Jack Shaw hosting East to West. Dr. Drexel Smith and I, we're sharing some information about our solar energy, nuclear energy, and traditional energy system. So by comparison, we're thinking about, of course, if we need to go solar, well, then we need to go nuclear. That's the solution according to him. But I was trying to test water, trying just test water by finding out if we can spend the same efforts or put the same efforts in the field trying to reduce the loss during the transmission. That will give us, well, a recovery of 95% maximum. So you're saying that you build smaller ones to shorten the distance of transmit. So that's what we are doing it.
That's one option. But Jack, I think if you look at our total energy issues, and let me speak around the world.
All right.
Because I think the world is now small enough that when one country does something, it affects somebody else. I think we need to look at the total solution. I'm a very strong advocate that I believe that nuclear power to generate electricity is something to be pursued. We should continue to develop those facilities to become safe and efficient. But to me, that's not the only solution. To me, there's an applicable use for solar, to transfer solar energy into heat, for personal water, for other uses. The direct conversion to electricity, I think, is very meaningful in many applications. I think wind has another application. Working with a company now that has a very exciting technology using a vertical wind turbine instead of a propeller that faces the wind. This is more like a vertical system that is less dependent on the direction of wind.
I see.
It looks like that the optimum use of this system is about a 10 kW system. Doesn't manufacture a lot of electricity, but it can work in very low wind speeds.
10K could be good for a house, right?
10K could be perfect for a rural house or a community center. Maybe there would be 4 of these to feed a community center in Africa to where they could have a learning center and computers.
Right.
Okay? We don't need to be building nuclear power plants in a lot of rural areas. There's other solutions.
So we're talking about a majority demand of energy.
That's right. Where you have large industrial bases,
I see.
obviously where we have a lot of power and a lot of demand, I think large systems like the nuclear systems are appropriate. But we should not stop the financial and sweat equity investments in looking at all alternatives. There's places in the world where we can use the thermal plower. They happen to have a natural well source where they can bring steam. It needs to be cleaned. It needs to have done a number of things. There's other technology issues, but let's look at that. We need to have every arrow in our quiver to fight this.
All
And
right.
to me, what we're fighting is, we want to burn less carbon fuel. It's not helpful to our environment. Carbon fuels have a limited life, even though they're highly efficient. We've yet to find anything that's more efficient than highly refined gasoline, because we get so much energy in a little tiny bundle.
All right.
15 and 20 gallons will let us go 300 miles. It doesn't bubble off. It's a beautiful fuel. The problem is, it's a very inefficient fuel from a burning of natural resources. And I worry that future conflicts are going to be more about conflict over resources than they are over territory, if we're not careful. And to me, the best way to avoid conflict is to take away the conflict issues. And to me, conflict over natural resources is a big issue.
So in other words, if we take all consideration, all the cost taken or sucked in the production of the one tank of gasoline that makes us drive 300 miles, can those energy themselves, for example, coal, drive 300 miles?
Well, or more important, can we develop energy storage systems, a la
Yes, yes,
batteries, that allow us to drive 300 miles on a charge?
Oh, yeah.
Yeah,
One
right now,
charge,
we
yeah.
can't do that. But my point to you is, look at the conflicts around the world today. In most cases, they're about resources. If we didn't have such a high demand around the world for oil, we wouldn't have an issue with Iran,
All right. Yeah. Okay.
okay? So if we can take away
I see what you mean. Yeah.
those arguments, I think we can minimize the number of conflicts around the world.
That's exactly the case. I'm glad that you mentioned that fact. You connect Iran with the gasoline. I mean, with the petroleum supplies. And the backup information is that Korea is doing the same thing. Why Korea calls less attention than Iran does. So
You're speaking now, of course, of North Korea.
yeah, North Korea, of
Yeah.
course.
North Korea is a major challenge. They've become such a closed society. I read with great interest this new young man that's now taking over the presidency, and his apparent interest in reaching out to the rest of the world. It's the next 2 or 3 years will be very interesting to watch that country. Him making overtures to the South about reunification. Obviously, it would be under his government, but I think he, unlike his father and grandfather, has some world experiences. He's seen what a robust economy can do. I hope he's not ignorant to what a poor economy has done to his country.
So you think by nature the Korean nuclear problem is different from Iran's?
Yes, I do. At least I hope it's different. I think
In
Iran,
what sense?
well, I think Iran has a different level of interest and passion that drives them to wanting to be a nuclear state. I think that there could very well be some tempering. I say this hopefully, Jeff. I'm hopeful that there's some tempering as to how North Korea sees themselves fitting in the world.
All right. Okay, assuming that the unpeaceful use or weapon use of nuclear energy is all taken care of, now we have only one issue left, which is safe use, right? Now that with the Chernobyl with Russia, and then
Fukushima.
Fukushima in Japan, right? So when these happen, so I believe the time when the engineers designed the Chernobyl and when the engineer designed the Fukushima, they knew that was safe, and they knew they signed off it is safe to operate, right? Like you say, I say here, right? So if something happens like that nature, something of that scale happened, and then a disaster anyway. So the safe use is still another issue. Even if an atom bomb, nuclear bomb kills, right? An accident of the nuclear plant still kills the same thing. So, do you think I make a point?
Of course you make a point.
Mm-hmm.
Jack, that's why I'm so fond of being with you. You always make a good point.
All right, thank you very much. Right.
But I think that the accident in Russia was a series of major mistakes. Not as much just in the design of the plant, but they made major mistakes. They were doing a test in an operating facility they just, looking back, should have never been doing. And it got out of control and away from them. It was way beyond the design efforts of the plant.
All right, okay.
Now, that plant design would never be built again. And unfortunately, you learn by mistakes, and we now have a place in the world called Chernobyl that just simply can't be used again. And I think Chernobyl was just a horrible, horrible collection of errors by the plant operators.
You're saying they shouldn't have tested on the operation system, right?
Well,
Yeah.
there's a number of things that happened in that particular plant that I think we've learned and remember the lesson well. I think that's a very different situation than Japan and Fukushima. Fukushima, as we now understand, was devastated by a tsunami that was far bigger than anyone ever imagined would happen. So the point of the matter is that the protection of the power plant from the sea was inadequate. That allowed the water from the sea to breach the protection systems and flood areas that were never expected to be flooded.
Submerge it.
You know, for example, the emergency generators that were used to supply power to keep systems operational, to keep the plant cool, were found to be in some cases underwater because the tsunami wave breached beyond expectation. So in some cases, Fukushima power plants behaved almost exactly as predicted, sadly enough. What was never predicted was a wave that large breaching the system. So what that did was to create a re-review of every power plant throughout the world in its ability to be subjected to flooding in a way that wasn't designed. Nuclear power core, where the fuel is, must be controlled and must be maintained to keep the heat energy from building up.
All right, okay. All right, let's take a short moment out, and when we come back, we will find out the most points that I'm concerned. So I'll let you know where I'm concerned. Okay, stay with us, we'll be right back. Hello, my dear friends. Welcome back to the discussion of nuclear energy. I'm sharing this information with Mr. Drexel Smith. He's a good friend of mine. He is a scientist involved heavily in national defense, and his expertise in safe usage of nuclear energy. And we're talking about the failures. We're trying to see how human can learn from the past failures, right? Putting all together, I'll let you know why I'm asking. I'm glad, as a Chinese American, I'm glad I'm learning China is doing the nuclear programs, right? For peaceful use purpose, for safe use purpose. And my concern is that learning those failures. of Chernobyl of Russia, and of Fukushima of Japan. I'm concerned about when you do consulting, did you put all these failures into consideration that the Chinese government knows what you're talking about? Or Chinese technicians or scientists knowing what they're talking about? Exactly. Or in other words, when you say the distance from the plant to water is too close or the projection is too short, should we build it on top of hills? Yeah,
Yeah.
should be.
Well, Jack, as always, you ask a fascinating question.
Or thank you.
Um,
I'm not too fascinated.
Yes, you are.
Mm.
In the United States,
Mhm.
we have developed an industry
Mhm.
that is very unique in terms of learning from failure. We don't criticize
Mhm.
when there's a problem.
All right.
We incentivize people to talk about problems.
Mhm.
And the entire framework of how we manage nuclear safety between the US NRC, the Nuclear Regulatory Commission,
Mhm.
the owners of the power plants, and the independent evaluators all work together to make sure that we're taking advantage of what's learned.
I see.
Let me give you an example. If there's a problem with a particular device, let's say a valve in the US, it is an obligation that you share what you learned about the valve with the entire community.
I see.
You invite ideas on how to fix it and how to make it better and how to minimize the problem. That is very unique. And one of the things that we've been talking a lot about in China is how does the Chinese use their, instead of NRC, they call it NNSA,
All right.
the Nuclear Safety Administration. How do they adopt and how does the industry adopt a similar support system
All right.
to help each other make sure that they're safe?
All right.
How do they implement the quality control procedures, the evaluation procedures? And those are the kinds of things that I've been working on as a consultant
I see.
in China, because other industries don't operate that way. This has got to be unique. It's
see.
got to be, there's no
I see.
room for failure.
But there is always a limit of know-how transfers. Do you see that point?
Well, of course, you encounter something that's new and unique.
Of course. And there is not always, there is always those matters or concerns or those issues which money cannot buy,
Well,
right?
I think that, let's go back to Fukushima for just a moment.
Sure.
We didn't necessarily need to build the power plant on a higher hill.
All right.
If we had simply recognized that the critical safety systems had to be out of harm's way, it would have been fine. What was absent was the emergency power systems
Oh, I see.
were below level,
Oh, I see.
okay? The power plants themselves probably could have survived okay, but
Oh, I
they
see.
couldn't survive without the emergency generators.
You're saying that if there is enough generator elsewhere to generate power to let the motor run, to still
And keep the cooling systems working.
pump the water out,
Exactly.
keep the cooling system going,
Exactly,
the plant will survive.
yes. Now, I don't know enough about the political system in Japan
I see.
or the technical arguments that may have taken place, why that problem wasn't uncovered. I think it began with an underestimate of the potential tsunami.
I see.
It then compounded with allowing the emergency generators to be built in sumps at a lower level. Could be that that was an economic decision.
Yeah. That's
That
why
was
I'm
an
saying
easy
that
place to put
bring
them,
it on top of the hills.
or put them somewhere else, or build them up
Somewhere else, or
higher.
maybe inland, more inland rather than on the coast.
Could very well be. My point to you is that I think that the world community, for people engaged in nuclear power technology, look at every one of these incidents, every time that there's a problem, be it a problem of a valve, the current problem we have at San Onofre with the steam generators, the entire world community is sharing that information to preclude that problem from happening
All right,
again.
okay. So more or less like what? Like international community that shares information, non-commercial information. I mean, there's once again, like I said, there's always a limit of secrecies, right? And there's also a limit to certain issues or know-hows, and there are even issues that nobody can buy. Whoever has
In this industry, there can be no secrets.
Oh, you think so?
In this industry, for the
Everything
power
is-
side of the business,
Everything's available for sale?
my view is,
Mhm.
and I will share with you, the attitude in China
Mhm.
of the government leadership,
Uh-huh.
the civil leadership,
Mhm.
the manufacturing process,
Mhm.
they recognize there's no room for failure.
I see.
They're very interested to make sure that they're viewed as a world leader, and they're very interested to make sure that they're staying up and sharing of that technology. I was personally very involved in putting together 2 symposiums of sharing information
I see.
about nuclear safety. So I suggest to you, in this case, in this industry, the Chinese made a decision to buy US technology and are participating in the world stage in nuclear safety issues. And I am very hopeful that in this particular area, we will share as world citizens outstanding technology that if managed properly can be used safely.
I see. So is it convenient for you to expose to what kind of stage has this program been so far conducted?
Well, I will share with you that we've been very successful in putting nuclear safety into the first AP1000 plant that should be completed in less than 2 years.
I see.
And plants 3,
Where
2,
they
3
gonna
in China.
In China, we don't know
Yes,
where yet.
yes. Yes, I just don't happen to.
Oh, I see, I see.
But there are 4 plants that have been purchased. Plants 2 and 3 are already in construction.
I see.
And I would say that from a safety system standpoint, the localization and use of Chinese manufacturers is very robust. The test facilities to test these things are underway, and I'm very, very encouraged.
You mean this is a state-run program, isn't it? NNSA?
Well, NNSA, the Nuclear Safety,
National Nuclear Safety
Administration.
Yes.
they are the same as the US NRC.
Supervise the project.
That's right. The owners of the power plant is SMPTC, the State Nuclear Power Technology Corporation,
Okay, SMPTC.
which is a combination of state-owned and private investment.
I see. All right. So they are supposed to be supplying powers to industrial area or to certain cities or a certain project?
Well,
Anything specific?
these first power plants are being designed for major industrial areas in the country.
And I know China, there are parallel system going on. I mean, going with this one, or probably at the same time, you're using one, you have to start building the next one, right? And just for time lag. Now we have the dams, the
In China?
Yangtze River dams, the huge one, huge project. What's your comment on that one? What's the status of that power plant?
Well, China truly embraced the idea of using hydroelectric power. Lots of debate about environmental consequences, people consequences of relocation of a lot of people to make those projects. You know, there's many people that believe that hydroelectric is a perfect way to generate electricity because you're using nature's water flow to turn a turbine, et cetera. I think that's offset by how much power can you generate, offsetting by the environmental consequences of building such a facility. My view is I would argue to build more nuclear power plants than to create such a significant environmental change.
Does your idea represent what's prevailing in China? In other words,
China
do you-
today has fully embraced nuclear as their future. The new China government just installed this past fall, re-embraced nuclear, and they have plans not for just these 4 AP1000s, but to build 50 plants
I see.
in the near future. So they see nuclear as a major part of their energy component
So
in the
that
country.
stands the prevailing concept of nowadays China development, right?
But remember, they took their entire nuclear program and went stop after Fukushima
Yeah.
and instituted a complete review of every existing power plant and all designs for future power plants. They, like the rest of the world community.
The Chinese are known to be good at learning from the past experiences, be it their own, be it from somebody else. It's the common resources of the human as a group, right? So I'm so glad that my good friend of mine is involved in such a project like this. I mean, you know, if this years later, from right now we're talking about 3 to 5 years later, we'll see the result, right?
Absolutely.
All right, let's keep our fingers crossed and stretch our ears to listen to see what's going to happen, right? I should say thank you very much, my audience, is to stay with us, and thank you very much for coming to the show.
Jack, it's always a pleasure.
All right, thank you.